Huygens' principle of secondary wavelets. According to Huygens' theory, a point source S sends out waves in all directions. In time t, the waves of light would reach a distance cx to equally in all directions in space, where c is the velocity of light. All the points where the waves have reached in the same time are on the surface of a sphere with S as center and radius equal to ct0. The sphere is depicted by a circle in the plane of paper. Since all the points on the surface of this sphere have received the waves at the same time t, therefore these are vibrating in the same phase. So this surface is called a wavefront. A line drawn perpendicular to the wavefront is called a ray of light. So all the radii of the spherical wavefront represent rays. In order to explain how a wavefront is propagated forwards through a homogeneous isotropic medium, Christian Huygens made the following two assumptions. 1. Each point on a wavefront acts as a fresh source of disturbance called as secondary wavelets. These wavelets spread out in the medium with the velocity of light in that medium. 2. The new wavefront at any later time is obtained by taking the forward envelope of the secondary wavelets at that time. Let S be a point source of light which sends out spherical disturbances in the homogeneous and isotropic medium around it. Let AB be a trace of a spherical wavefront at any instant t0. Each point on this spherical wavefront is a source of secondary wavelets. Starting from different points of wavefront at any instant t0, the secondary wavelets will travel a distance c delta t in time delta t. So each secondary wavelet will be a sphere of radius c delta t. The forward envelope CD of all the secondary wavelets gives the position of the new wavefront after time delta t. So a spherical wavefront advances as a spherical wavefront. If the radius of the original spherical wavefront is infinitely large, then it appears as a plane wavefront, as it can be shown from considerations of superposition of waves and the phenomenon of interference, that the amplitude of particles on a backward wavefront is zero. Another important point to be noted is that only the point where the envelope CD touches the secondary wavelet is effective. The effects of all other points of the secondary wavelets cancel each other.